Hello everybody, welcome back to my channel. Yesterday we finished the fourth problem on LeetCode, median up to sorted arrays, and today I will continue with the fifth problem, longest palindromic substring. It is a medium one, not so difficult but not so easy. Okay, let's start. Given a string S, find the longest palindromic substring in S. You may assume that the maximum length of S is 1000. The first example, input is BABAD. The output should be BAB or ABA. Both of them are valid answers. The second example, we have CBBD and the output is BB. So that's the description of the problem. So we may think of some other test case, such as if no palindromic substring, so return empty string, or maybe the whole string is palindromic, like for example A, B, C, C, B, A. So we have to return the whole string. Also some other normal case like let me put the number here 1, 2, and 3. When we have many palindromic substring inside, for example, we have A, B, C, C, B, A, but then if we go through C, C, we may have D here, and we put B, D, C, C here. So if we have A, B, C, C, D, B is 6, but if we have this one, C, C, D, B, A, B, D, C, C is much longer. It has 9, so we have to return CC, DB, ABD, CC. So the problem here is that we have to find the longest substring, and that longest substring may contain a part of the other palindromic substring. So it seems like we should not pay attention to the beginning of the substring. We should think about in the middle of the we should think about the middle character of the substring. For example, here, if I iterate through all the character of the string, I should check the the substring that character is in the middle. For example, if we have this one, so now we go to the solution. Here we have this one, and when we iterate to A, we find the next, and to see whether it is the same or not. If not, we will go next. And so, for example, with A, we cannot find anything, so we stop with A. With B, we can have, with B, ABC is not palindromic, so okay, palindromic, so it's only B. With C, we see that the next one is also C, so we have CC. And if we consider C as the middle of a substring with the odd length, so B, we have to compare B with C, so it's not equal, so okay, just let it. So we stop, and here we go to the next C, so we have nothing better. When we go to D, we have no other good thing. With B, nothing else also. And when we go to A, and we see the next one is not A, so if it has a substring, it should be in the middle. So we consider B and B good. So we go further, D and D good also. And we go further until we reach the final one. We have CC, DB, AB, D, CC, and that is the result we have. So, and we can see here that if we go to at any character like in A, we go until the end of the substring. So it is good size to show that there's no other better substring as a longer substring. So we should stop here because we reach the end of the string, so we can break here. Okay, so now we will implement the solution. First, we have to check whether the length is bigger than 0 or not. I mean, if it is equal to 0, so return. Yeah, okay, so now we make sure that as always contains at least one character. Then we have to make a while loop. We will start at the index equal to 0 and y index still smaller than s length. So we go to the iterate. First, we have to check if index plus 1 is smaller than the length. Then we compare it S. Compare it with the next one. So here we have to have a string result to save the result of the procedure of the method of the function. Here we will make another string, current substring. So if this one, the character index equal to this one, we have to go further. First, we will set substring we will get a string of 2 characters. So I have to check again to see the substring methods. Here we have begin index and end index. So the begin index is index and the end index is the next one. Like here, for example, it's so long. We have to count to see. Okay, here is much shorter. So we have let's learn server and substring 1. So it removes the error. It starts from E. And if substring 1, 3 is return ET, so it will get from that index to from start index to the end index minus 1. So I think that's good thing to put. And here, after that, we have to go further until it's different. So we need another index, brief index. We set it equal to index and then y pre-index still bigger than -1. We go further. No, bigger than 0. We go further, so pre-index it should be -1. Y pre-index is still bigger than this one. And the ones that is the one that we will compare, we have to we have to compare. For example, here, if we have BABAD, BABAD, and when we, for example, here we have BB, and Z is the index. Z is pre-index. So we have index is 2, pre-index is 1. So we have to calculate here 0, 1, 2, 3, 4. So here is 4. We have to compare with 4. So how we can calculate it? So it should go through the index. So here is the index, and the index minus 1, we have to compare with index 8, index plus 2. So like here we have index minus num backward, and here we have to the one that is palindromic character is at the index plus nums backward plus 1. Let's check again. So here we have nums backward is 1. Here we have index is 2 plus 1 plus 1 is should be 4. 0, 1, 2, 3, 4. Good. So okay. So here we have to count the nums backward instead of the pre-index. So we start with 1, and why the index minus num backward still bigger than 0, and this one still smaller than S length. We go forward. So it seems like we should not save it as the string. We should get the integer max length. It looks better. And we also have integer the center index. So here we will put the we will have the integer current length here, and we put here 0, and here, because it's equal, we will have the current length equal to 2. And why that one happened? We will compare In that case, we increase curl length to 2 and we set the nums backward. We increase it. And whenever we reach the position when the both characters are different, we have to stop and compare. So if the curl length is bigger than max length, so we set max length equal to curl length and we set the center index to index and we break. We don't have to continue to go backward again. But in fact, we have to think that there's a situation when we finish the while because it reached the end. And at that time, because it do not go to that else block, it would not replace the max length. So it seems like we should not compare and set the max length here. We should move it outside of the while block. So here is the end of the while block and we have to compare it here. So it means that else we break. Okay. So we already check the substring that has the same, the substring with the even length. Now we have to think about the substring with the odd length. So it would be out of this. So here we have to check if the previous one, so that index is in the middle, like here is in this position is A, and the previous and the next path of that is equal to each other. So we will check it here. It's just check the substring. We have substring. We see that we have to reset the current length again. So it seems like we don't have to check if this one. We have to do the whole loop. Start from this one. So here, when we want to check the substring with odd length, we start all of this one. We reset the current length to 0. The nums backward is -1. Is 1, sorry. And so we do a while loop. But this while loop is a little bit different. So we have this one, we don't have to use this one. So, and within the while loop, we will check. So the current length in this case is 1 because at least it have VA1. I mean the length which contains only one character. Yep, so it seems like we also have here we have here we may have another test case with a string with only one character. I mean no, so here it should not be no palindromic string but an empty string. So return that, but no but not, I mean is non-empty string, but no palindromic substring, so it should return one character. Like for example, like we have A, B, C, D, and then we return A. So here, this that test case, we have current length is 1 and number scores is 1. So here if that one is equal, so we do the same thing with here. Nums backward error break, and we also compare so we also have another way to make it run faster, that if we reach that mark length and we reach the, so here we don't need the break here and no break here. We will break in another situation. Mean here, if we reach like when we check this one is equal or that one is bigger, it means we reach the end of the string and we cannot find the better one. However, it's better to check this situation before we make it, before we optimize it. So after we iterate through the whole string, we will go and check and return. So the result here is equal to S substring start from sorry. So if max length it means if it's an even string, so we will start from let's see here, we have this one and we have the max length is 9 and the index is here, so 0 1 2 3, so we should start from 2 3 4 5 6, so the center is 6, 7 8 9 10, and the final is 10. So we should get the substring from max length. This one is different from 0. From max length from center minus max length divide 2, then center plus max length divide 2 plus 1, because so here we will have 6 minus 4 is 2, and 6 plus 4 plus 1 is 11, so it will go from 2 to 10. And in another case, for example, here we have A, B, C. I mean, for example, we have C, B, B, D. So with C, B, B, D, the max length is 2. Center is 0, 1. So we should get from 1 to 2. So it should be center minus max length 2, 1, 2. Oh, sorry, it's not that. It's a comma. Okay. And here is center minus max length 2 minus 1. So here is 1 minus 1 plus 1 is 1, and 1 plus 1 plus 1 is 3. So it's look good. Just let's see. We will return result. So that is the final one. So what's that? This one, the Y. Which Y? First Y. So this one should be here. It belongs to this Y. Okay, let's check. Okay, sorry. We reset it, not mean we create it again. Cannot find the symbol. Center is not center. It should be center index. Okay. Time limit exceeded. It's so slow. Okay, but at least we have to print out to see how it runs. Oh, there's another problem. I forgot to increase index. Okay, it good though. So that's the first example. Let's see the second one. And sum up our example. Here we have empty one. We have the whole string. We have no palindromic substring. We have many one, but it should give the best. So it all accepted. Okay, good sign. So I have to remove all the print command. So that I can make sure it doesn't run so slow. Like this one, and I run again. Okay, it looks good. So I will try to submit it. Okay, so it's faster than 68% of the submission. So it's okay, but it's not the best solution. Now we should see how can we optimize it. So it's the easiest way is that I see whether the distance from the index to the either side is bigger than max length or not. Uh, if not, I should break. Like here, I should not run through the whole um, string. I have to check if, for example, from index example here we have A, B, C, D, E, F. So we have from 0 to 1, 2, 3, 4, 5, 6 to 6. So the length is 7. So if from like we have mark length equal to 3, and I know that s length minus index is smaller than max length divide 2. So I don't have to then write again, because even I run that loop, I calculate I cannot have the better one like here. When we from s length is 7 and like we have mark length is 3. So if we run to the index here, it is 5. No way I can find a better result. So if the index equal to 5, I have to quit. So s length is 7 and index is 5, and this one is smaller than or equal than that. Here we have 7 minus 5 is 2, and max length divide 2 minus 1 is 0. So no, should be minus plus 1 is 2. So no way. And even if the mark length is 4, so it doesn't make sense to run anymore. So let's see whether it's faster or not. Wrong answer. Input is A and the output is okay. So it happens when it's at the egg border where we have only one. Only one character. when we run to 2, we have to okay, so it's run faster than 94% of the Java submission. So I will stop here and I will check the solution to see what is the best solution. I think here is kind of okay problem, but I want to see what is the best one. So yep, you may see the whole code here. I will let it here so that you can see it. First we will set if the length is smaller or equal to 1, we return it. Then we only run when the number of characters of the string is bigger than 1. It goes from 2. We initiate all the value and then we go here. We make a while loop to run through all the characters and we check if we already have a good result, and even when we run and we find another substring, another palindromic substring, it cannot better than the max length, the result we already have. So this one is if the index, if find a palindromic substring with this index, it will not better than the result we already have. We already have like than the current max length. So we break. And now we start with checking the substring with even length. We set the current length to 0, nums backward to 0, and we run to both direction and we compare it. And if it is if these characters are equal, we add it to the current length. And whenever we see the difference between two characters, we break. And after we finish the while loop, we compare it with the max length we already have. The same one with the substring with arc length, like for example, like we have CPC, or here we have sample CBBC. And finally, we have to get the substring from the information of the max length and the center index. It's just a small difference of the mathematical between the two types so that we can get the correct substring and we return the result. Okay, so let's check the solution. It explains a little about the palindrome. So ABA is a palindrome, ABC is not. Approach one is a long brute force. We make bigger than it, so we make faster than that at first, so I don't care about that. Solution dynamic program. It seems like what we come up with. BAB is a palindrome. It's obvious that ABA must be a palindrome. Two left and right hand letters are the same. So here they base on the smallest substring and they go further. So that's exactly what we did there. The time complexity is ON. Yeah, I'm sorry, ON square. Yeah, it seems what we do here because we have two while loop. This one and this one, so it's ON square, and we just make a kind of easy way small trick to make it run faster. So the problem of that solution is the space complexity is ON square. We don't use that much. We just use a small one, so only constant space. Yeah, we use the constant space. So it seems like it's similar to what we come up here. Oh, it look like they use a recursive. No. Yeah. Let's see. Length one, expand around center. That's one. Length two. It seems like they have the expand around center somewhere. And it should be the recursive one. Yep, I think the programming technique may make it run better than us. But yeah, I think it's okay with that submission. and maybe next time I will try to use better technique. Thank you for being with me to solve this problem. See you later with the next problem. Bye bye.